Hello and welcome to this episode of IDIS Technology Bytes. In this tutorial, we will review the configuration of IDIS cameras in DirectIP mode. IDIS cameras are shipped in DirectIP mode by default. This provides all the advantages of the DirectIP protocol and no camera configuration is usually required. However, this video demonstrates the configuration features that are available. IDIS cameras may also be changed to IDIS mode, also known as Open IP mode. In this mode, they behave as standard IP cameras with on-VIF capabilities. Changing a camera from IDIS mode to DirectIP mode can be done within the NVR camera registration page by clicking on the tool icon and changing the mode of the selected cameras. Once the camera is registered to the NVR in DirectIP mode, all camera configurations are performed via the NVR. This removes the need for a computer to access the web server of each camera. Most other camera-specific configurations are found in the Advanced Setup menu. One or more privacy masks may be defined for each camera. This will remove the masked portions of video pictures from an operator's view. After enabling privacy masking, enter the configuration screen and simply click and drag over areas where masking is required. Save, name, and apply your new mask settings. PTZ camera settings are defined here. Click the preset box to define or edit camera preset positions. Highlight the correct preset slot and move the camera to the desired location. Use the Set button to assign the preset location. Name the preset slot and repeat for all desired presets. A PTZ scan will automatically move the camera at a defined speed between two preset positions. The dwell time at each preset can also be defined. To set up a new scan, click the desired slot and the Set button. Choose the start and end presets as well as the scan speed and dwell time. Name and save the scan. A PTZ pattern records a set of user control inputs to the camera and repeats this sequence in a loop. To set a new pattern, click and name the desired slot. The interface will start recording control inputs and timings. Using the camera controls, move the camera in the desired pattern and to all of the desired positions. Click on the Stop Recording button when complete. The Test button can be used to replay the movement sequence. Click OK to save the patterns. A PTZ tour is a defined sequence of presets with a dwell time in each preset location. Click the desired slot and the Set button. Pick the desired preset, scan, or pattern in the function column for each tour position. Choose the dwell time and speed and save your settings. All of the above PTZ functions can now be invoked from the on-screen PTZ function menus. Another unique benefit of the DirectIP protocol is that individual cameras can be power cycled and also factory reset from the NVR without the need for physical access to the camera. Internal camera parameters may be accessed by clicking on the video slot. This will open a camera-specific menu system. Image sensor settings can be adjusted here. Enabling backlight compensation will result in foreground objects receiving higher exposure in backlit situations. Increasing the sharpness setting can increase the clarity of objects, but can also lead to more unwanted noise. The noise filter setting can reduce the amount of noise in low light scenarios, but may result in blurry images. 3D noise reduction can reduce noise without resulting in a blurry picture, but may introduce ghosting. IR mode controls the camera infrared filter. The auto setting will automatically enable or disable IR mode based on ambient lighting conditions. Some cameras feature refocus mode. This will readjust the focus of the camera when changes in infrared mode is detected. This removes the common problem of focus differences between day and night modes. Some bullet cameras feature a PIR sensor and white illumination LEDs as a deterrent feature. This option is used to enable or disable the LEDs. Black and white mode allows images to be displayed in grayscale during low lighting conditions. Auto mode will control this mode automatically. Sometimes even infrared light can reflect off white surfaces and cause exposure issues in a camera. The strength of the infrared light can be controlled to assist with this issue. Some cameras feature an advanced AE mode. This will assist in providing more exposure for dark areas in mixed lighting conditions. An example would be reducing glare from a car headlight in order to view the license plates. Daytime and nighttime switching levels can be controlled here. In certain situations, the user may want the night mode of the camera to be enabled earlier than the auto feature would normally enable the mode. The camera picture may be flipped horizontally and vertically to accommodate various mounting options. White balance adjustments can assist in correcting picture colors affected by artificial lighting. A number of presets are available that take into account the color temperature of various types of lighting. Manual adjustment is also available to set the gain of red and blue values. Exposure parameters of the camera can be adjusted if required. An auto exposure mode is available and the user can set a target gain. A higher gain value will result in a brighter image. Use the local exposure setting to compensate for dark areas due to backlighting or on overexposed images. Lighting sources in the camera view that use AC current may produce flickering images. By matching the frequency setting of the lighting source, flickering may be eliminated. When slow shutter mode is enabled, images may be brighter in low light conditions. True wide dynamic range enabled cameras allow a balanced view of both dark and bright areas on the same video picture. This is especially common in situations where cameras are aimed at entrance doors and windows. When using box-type cameras, the user can specify if an auto or manual iris lens is used. Shutter speed may be controlled if both anti-flicker and slow shutter are turned off. Manual mode will allow the user to set the shutter speed for custom applications. View mode applies mainly to fisheye type cameras. Camera side dewarping will produce a few choices of image layouts. Use the original image setting for client side dewarping. Some cameras feature an image stabilizer to reduce picture blurring that results from mechanical shaking of the camera. This feature can be enabled here. Well, that's all for this topic. Thank you for watching, and please see our other videos for more tutorials on IDIS products.